सर कोड में तो कोई दिक्कत नहीं है सर। ई टैब्स के सर जो आपने मॉडलिंग दी थी ना सर, उसमें एक डाउट थी सर।
पूछिए। एक्चुअली वो
उसमें सर जो
देखिए, हाँ।
उसमें से जो बेसमेंट में सर जैसे रिटेनिंग वॉल आएगी ना, तो उसके
हाँ,
मॉडलिंग को लेके सर क्वेश्चन था सर।
क्या क्वेश्चन था? विल सी इन द ETAP सेशन, बट लेट मी नो योर क्वेश्चन।
कि सर मतलब जैसे सर लिफ्ट के केस में सर शेयर वॉल आ जाएगी, तो सर बेसमेंट के केस में सर हमें नॉर्मल मतलब वॉल रिटेनिंग वॉल किस तरह से मॉडल होगी सर, वो पूछना था।
Right, right. We'll go ahead with that. There are two choice actually. You can construct a retaining wall which will be from basement to ground, and above there will be no wall. And if you need a supporting structure, you will create columns through that, or you may forget the retaining wall in the modeling, and you can assume some hypothetical column size at required spacing, and you can model the entire structure without retaining wall, because that see, design of retaining wall is different than design of shear wall, right?
यस सर, यही डाउट थी
So,
सर कि
yeah.
वो फिर कैसे होगा
So
सर।
there are choice. See, as per your convenience, you can use that. Normally, what happens if you are creating a retaining wall right from basement to your ground level, then it gives you a sturdy or rigid structure, and because of that, you may in analysis you may get lesser base shear. So instead of that, we'll consider higher base shear without modeling that retaining wall.
यस सर।
Finally, finally, we see the first thing is that we are never interested in exact analysis. We are interested in finding out what maximum that you can consider so that your structure will be safe. So you can delete that retaining wall. What you will draw that in your AutoCAD drawing, and you will design the retaining wall as per retaining wall principles. But you will not model that in the analysis, so that the model will become a little bit flexible, and it will give you higher base shear. So getting higher base shear is good, no?
यस सर।
Yeah. Definitely, it will be a little bit conservative, but even if your design is a little bit conservative, that is good because you are not losing a lot of economy but you will get safety.
यस सर।
So, so that is how it is dealt by engineers. But if you want to create that, you can have uh, the ground level shear wall. So you will have the wall, total length of the wall from one point to another point, and it will be drawn from base to ground,
यस
right?
सर।
And later on, you may provide lateral forces on that wall, so that retaining the forces that are generated due to the lateral restraint applied due to the feeling outside the retaining wall will be applied on that, and you may create your model that way also.
यस सर।
Yeah. Any other query or something about whatever how the things are going? Will go through that because actually in your syllabus we have not included that reading 1893 and 13920, but I have done it on my own because whenever I used to ask the people, they just say that, sir, we are working on it. We are reading, but I know that having a little bit resistance to go and read IS codes, वो जनरली है। आप में से कितने लोगों में वो था कि नहीं लगता है, आज चलो किसी से पूछ लेंगे व्हाट इज द कोडल प्रोविजन, बट विल नॉट रीड थ्रू द कोडल बुक्स और वट एवर कॉपी दैट यू आर हैविंग, क्योंकि दैट इज आई ऑलवेज फाइंड इन प्रैक्टिकल considerations also. Many people who are working practically, they are working as a structure engineer in big firms, and they are carrying the senior position, but they are asking someone, what is the codal provision for this, what is the codal provision for that. But people are, I don't know why, but people are hesitant to go through the codal provisions by themselves. किसी से पूछ लेते और वो बंदा उसको जो समझाए वो बता दे, नहीं नहीं वो कोड में ऐसा दिया है, और ये वही एक्सेप्ट कर दे, नहीं नहीं वो कोड में ऐसा दिया है कि बॉटम का रीएनफोर्समेंट का 50% ऊपर चाहिए, ऊपर का 50% नीचे चाहिए, कुछ भी वेग। they don't go through actual statement that are given by the code for unknown reasons. I don't know. ऐसा तो कुछ नहीं है कि द कोडल प्रोविजंस आर रिटन इन चाइनीज लैंग्वेज सो नोबडी अंडरस्टैंड्स, ऐसा नहीं है ना, ये सिंपल इंग्लिश ही है। यस और नो?
Yes, sir.
मगर पढ़ते नहीं।
Yes, sir.
ऑनेस्टली बोलना, ऑनेस्टली बोलना कि कितने इसके पहले कितने आपने कोडल बुक निकाल के वो एक्चुअल कोडल प्रोविजन रीड करने की, समझने की कोशिश की है, एक्चुअली नॉट आस्किंग समवन एल्स। वो होता है ना कि आप सीनियर को पूछे, आपका सीनियर उसके सीनियर को पूछा है।
Hello.
सर का नेटवर्क नहीं शायद से।
Network problem.
हाँ
I'm asking all of you
Excuse
that
me, sir.
how you are feeling कि कैसे
So, so there is a network disturbance.
Hello, am I audible now?
यस
sir.
सर. सो
Yeah.
बीच
So
में सर आपका नेटवर्क पॉज हो रहा, मतलब थोड़ा नेटवर्क इशू
नहीं
आ रहा था
पॉज
सर,
हुआ,
तो कुछ सुनाई नहीं दे
नहीं
रहा था.
पॉज हुआ, नहीं पॉज हुआ, उसके बाद मैंने डिस्कनेक्ट किया, मैं बोला रीज्वाइन करता हूँ, तो रीज्वाइनिंग में समय लग गया.
यस सर.
Yeah, actually, see, when the weather is cloudy, there is always a problem. And right now in Pune, at least where I stay in that area, the weather is very, very cloudy, and that's why maybe. Uh, so we'll go straight away to that. Okay. So now I am audible to all of you.
यस सर.
Okay. So let me present first. So that is the part most of the time I forget. Yes, Hima, Kedari, Ketan, Samir, Shaji, and Suleka ma'am. Everybody is there except Avinash. पता नहीं अविनाश का
वो
नेटवर्क
अविनाश,
नहीं है.
अविनाश भाई की सर वो तबीयत थोड़ी सही नहीं है.
अच्छा अच्छा
उन्होंने सर
तो
ग्रुप में मैसेज डाला था अभी.
अच्छा अच्छा. So he will go ahead with the recorded. No problem.
यस सर.
Okay. So oh, this was where we started. Okay, we were at this somewhere here, right? ये दिख रहा है अभी? हेलो.
No, sir.
नो सर.
क्यों?
हाँ
प्रेजेंट तो किया है.
यस
हाँ, आ गया
यस
सर,
सर.
अभी
अब
आया.
अब दिखा है सर. वो
अभी अभी दिख
थोड़ा
रहा है.
लैग कर रहा है. हाँ सर, अब
Yes,
दिख
sir.
रहा है सर.
Yes, अभी दिख रहा
Okay, okay. Okay, then this was what we were discussing. That requirement for so beams axial compressive stress shall not exceed 0.08 FCK. That means the members that we are whatever you are calling as beams, code is taking care that they are not actually stressed. Okay. Then this was what we ratio shall not be less than zero point 0.3, or in code terminology, beam shall preferably have width to depth ratio more than 0.3. Shall not be less than 0.3, or you may say more than 0.3. Then this was also we have discussed it shall not be less than 200, and then depth of the beam shall not be more than 1/4 of the clear span. So beam shall not have depth D more than 1/4 or L by 4, you can say. All these are just for so that the beam, size of the beam is well within the behavior limit. Okay. Now, if you want, see, normally what is happening, let's say, many times this is a situation. Let's say you are having a column like this. This is your column. Let's say this column is having depth of size as 300 by say 600, and you are having for that you are having width of the beam, maximum width of the beam on this line. How much will be maximum? Yes,
Size of column.
size of width of column. I will say width of column, or in this case, maximum will be this. This is what we see physically. But let us say that this is your column, and you are having this width of beam 300, and let's say you are having this beam is heavily reinforced at top and bottom, so that you need depth width of beam more than width of the column. What will happen? Then you will say that this is your depth, this is your width. So I will call this as BW. Yes. So width of the beam, I need, let's say I need width of the beam BW, which is exceeding width of the column. So in that case, what should be done? How this beam will rest on the column? So for that, this is the provision that code is saying. Okay, clear?
Yes, sir.
सिचुएशन समझ में आई आपको? See, already the beams are the columns are designed by you, and the construction work is going at site. The people there have raised, and then let's say for some XYZ reason, now you think that width of the beam has to be greater than width of the column. So is it possible? It is possible, provided you go through this. So what he is saying, that width of beam BW shall not exceed width of the supporting member C2 plus distance on either side of the supporting member equal to smaller of A and B. Now what is that A and B? It is saying that width of supporting member C2 on either side and 0.70 times breadth of supporting member C1. That means you can check it over here. Let me have it like this. Now you may be understanding it. So this is your C2 and this is your C1, and you are having in plan width of the beam like this. And if you see, this is the arrangement. Now you can see this is BW. Okay. Now that BW on this side and on this side, you can increase the size width of the beam in such a manner that the increased portion on left as well as on right side shall not be greater than smaller of C2 and 0.75 C1. Clear?
Clear, sir.
And in that case, you have to provide a reinforcement in the beam. Now this is plan, and in the beam you can see the reinforcement has been provided in such a way that effectively it will transfer entire shear force or top moment on the column effectively, provided you're not exceeding these limits. So finally, I will say, if you write it, so I will say BW will be equal to, this is C2. So this is distance C2. Okay. Plus on this side C2, on this side C2, that is twice C2. Okay. Yes.
Yes, sir.
So that means three times width of the column. So this is your first calculation. Second calculation will be equal to C2 plus 0.70 times C1, 0.75 times C1 on this side and on this side. That means it will be 1.5 times
1.5.
5 times C1. This is your second calculation, and lesser of first and second will be your BW. Okay, clear?
Clear, sir.
But when you are having, then you must go for this detailing. And now you can, I will say that you can understand the reading. Okay, let's see what he is saying. See, in this 0.75 times C1 or C2, whatever it may be, smaller of this. Okay, in that case, you have to go for one close ring, and there has to be a reinforcement at the bottom and at the top. So minimum 3 at bottom and minimum 3 at top, and you will see that a stirrup will be like this. Then same will be like this, and in the remaining area you may have whatever your reinforcement that is required as per your calculations. So most of the time you will see that near support you are having hogging bending moment. So the curvature is in a hogging sense. That means you need a reinforcement to be applied at top, and then you can see that now you can place properly, so that your reinforcement will be like this, and detailing will be such a way that you can provide it. Okay. Now, why the code is giving you a permission to increase the width of beam on this side, because of heavy hogging bending moment at top, and your let's say you need a seven number of 25 dia bars, or let's say five number of 30 25 dia bars at top. Already you are having two normal additional five numbers, so there will be seven number of bars. Yes.
Yes, sir.
Are you getting the situation and the appropriate solution? You can check it over here. See, here you are having a reinforcement of column. Already this column may have something around uh, 12 bars or 20 bars, depending on its size. Already the vertical bars are coming in that joint, and these are the horizontal bars that of beam at top and bottom. So joint becomes such a what you will see that it will get overcrowded, and there is a lesser amount, or you will say that during construction you will not be able to pour the concrete, right? And there will be voids, indicating the joint will get weaker, and we'll come to that why the joint should not be weaker in case of, because in that case, whenever lateral forces will come in picture, and they will start vibrating the structure, already that joint is weak, so it will get cracked, and if the joints are cracked, your building will form a brittle failure, which we want to avoid. Clear?
Yes, sir.
सो सारी चीजें एक दूसरे के ऊपर है, एंड nobody will tell you this. Actually, I don't know why maximum people are having that block in there. Let's say this is my column. Okay. And let's say the size of the column is 450. And this is, let's say this is also 450. And this column is supporting a beam which is having a 10 meter span, right? So somewhere here you are having a column, another column, and this column is having a 10 meter distance, and this is a commercial project. Definitely this column, this beam will be subjected to heavy loading. That's why it will deform. It will need more reinforcement at top, more reinforcement at bottom, and you're blocked in your mind that you cannot have a width of beam equal to 450, more than 450 है, ऐसा है? अभी तक ब्लॉक थे?
Yes,
यस.
sir.
तो हम बोले यार क्या करेंगे, तो ये कॉलम का साइज ही बढ़ाना पड़ेगा. अब कॉलम का साइज आप बोलेंगे ओके, देन आई विल हैव टू गो फॉर 600 by 600 as a column, and actually this column does not need that much area, and even the architectural features does not allow you to go for big size of columns, right? And then people come in and say that नहीं यार वो beam बहुत heavy होता है, और फिर you will force to provide set 7 bars or whatever in first layer, then second layer, and third layer, and in that case, the depth of the beam or the effective depth of the beam will get reduced. All that can be solved provided you know this idea. And I can assure you that maximum number of people do not have this idea, because code has considered all these things. And the best thing is that every bar, the first thing or primary thing is that every bar should be surrounded by concrete on its periphery. No bar should be adjacent to another bar without having a concrete. Otherwise, how the development length will the development of concrete and reinforcement will come in picture. Bond है ना.
Sir.
And if you go and see 456 in the flexural conditions, you will find a clause that says that the bond between concrete and steel is kept intact right up to failure. मतलब बीम फेल होगा, कॉलम फेल होगा, कंक्रीट फेल होगा, रीइंफोर्समेंट फेल होगी, मगर बॉन्ड नहीं फेल होगा.
यस सर.
और याद आया वो?
यस सर, दिया हुआ है सर उसमें क्लॉज. अगर रेनफोर्समेंट भी फेल होगी तो सर वो ब्रेक हो जाएगी, पर बॉन्ड ब्रेक नहीं होगा.
यस. तो ये जो है, अगर ये बॉन्ड ब्रेक नहीं होना चाहिए तो सबसे पहली रिक्वायरमेंट क्या है? पहले बॉन्ड डेवलप तो होना चाहिए. ये सारा कंक्रीट होना चाहिए ना.
यस सर.
मान लो अगर कंक्रीट आपका ऐसा है, इतना ही है, इतना ही कंक्रीट है, और इमीडिएटली दूसरा बार आपका ऐसा है, तो यहाँ पे कंक्रीट है क्या?
नो सर.
तो बॉन्ड डेवलप होगा क्या?
नहीं होगा सर.
मगर हम लोग उस पर ज्यादा ध्यान नहीं देते, बिकॉज वी आर नॉट वरीड अबाउट दैट. हम लोग बोलते नहीं नहीं, वो साइट वाले जाने. साइट वाला क्या करेगा भाई? अगर तुमने ये रीइंफोर्समेंट और ये रीइंफोर्समेंट, ये दो बार्स में, इफ यू हैव प्रोवाइडेड ओनली a 15 mm distance and the person is pouring concrete from up, यहाँ पे वो कंक्रीट आएगा ही नहीं ना, तो बॉन्ड डेवलप होगा ही नहीं. और बॉन्ड डेवलप होगा ही नहीं तो ये फेलियर, ये तो गया आपका. डज नॉट फेल राइट अप टू फेलियर. और पहले फॉर्म ही नहीं हुआ, फेलियर का बात ही नहीं है. क्लियर?
यस सर.
And all that, if you consider all that thing, then code says that yes, you can go with this. You can increase the width of the beam, because in case of heavy reinforcement at top and at bottom, definitely in that column area where there is a beam and column joint, you will not be able to provide all reinforcement within that small area. So it is better to increase the area. वही लॉजिकल सॉल्यूशन है ना.
यस सर.
So this is how you can achieve it, provided you go through the codal provision and try to understand the meaning behind it. And now you can see that everything is clear. यहाँ पे बॉन्ड फेलियर होने का कोई चांस ही नहीं है. ये आपका रीइंफोर्समेंट आपको कैलकुलेट करना है, बट आई एम वरीड अबाउट बॉन्ड. तो बॉन्ड you can check, these are the columns, these are the reinforcement, these are the reinforcement of columns. Okay, and this is your reinforcement of beam. Yes.
Yes sir.
Large area mila, so concrete can be poured in this, the joint will not fail. Yes.
Yes sir.
So this is how it is practically achieved, provided you go through the things, and you can see that maximum effective width of wide beam, and that is why it is called a wide beam, and required transverse reinforcement. अब इतना क्लियर देने के बाद भी हम लोग बोलेंगे कोड वालों को कुछ समझता नहीं, कितना गलत है देखो. That is how people say. Clear?
Clear, sir.
Okay. Now you can read that, and see, whenever you are not understanding, again I will say that go ahead and draw the picture and try to see uh, the meaning for that. You will understand it. Okay. Now this is about longitudinal reinforcement. So definitely minimum and maximum. And now this is very important. Beam shall have at least two 12 mm dia bars, minimum 12 mm dia, two number of bars at bottom and top. Whether that is required as per your analysis or not. Minimum two at bottom, two at top, and the diameter has cannot be less than 12 mm. हम लोगों को वो practice है, we are using 10 dia bar at top. Yes.
Yes, sir.
That is okay when you are going to design only for gravity loads. But if you are going to design the building or structure to resist the lateral loads, then minimum longitudinal dia bars is 12 mm. Okay. Then minimum longitudinal steel ratio. So you can say minimum percentage of steel. Now this has been revised. 456 you will find a different clause, which is something 0.85 over Fy. Okay. And what is the difference between that clause and this clause? See, the minimum longitudinal steel ratio or minimum percentage of steel in earlier codal provision, or if you are going for IS 456, you will see that it depends only on grade of reinforcement, because it is 0.85 over Fy. Yes.
Yes. Yes.
That means the same will be applied to M20, same will be applied to M25, same will be applied to M40. ये illogical नहीं लगता है क्या? That has been covered over here, and okay, that is okay whenever you are going only for gravity loading. But when you are going for lateral load resistance system, your rho minimum depends on FCK and Fy as well, right? So that is how the code has revised the minimum percentage of reinforcement, longitudinal reinforcement in beams, or that 456. Now, if you now you can go and read 456 for minimum percentage of steel in beam, and you will see that the code says something that 0.85 over Fy. That means it is depending only on Fy. Now here code is taking care that it depends on grade of concrete as well as grade of reinforcement. Clear?
Clear, sir.
Yeah. And then this is about maximum. Now, why this maximum clause is coming in picture? Anybody can explain me that?
Placement of concrete will be difficult.
But see, why the code says that it shall not exceed 0.025 or 2.5%. See, rho max is AST by BD. Okay, and percentage is AST by BD multiplied by 100. That is the only difference between percentage and rho minimum and rho maximum. See, code says that this AST by BD, AST by BD shall not exceed 2.5%. multiply 100. So 100 AST by BD shall not exceed 2.5, or you can say 0.025. That means whatever is your BD, let's say if I call this as AST, so AST max shall not exceed 0.025 into BD. Clear?
Yes, sir.
What is the reason behind this? The first thing, whatever Samir has correctly said, that congestion of steel, to avoid congestion of steel. And second thing is that uh, over reinforced sections are disallowed. Clear?
Yes, sir.
Yeah. So to take care of the see any beam, and what will happen if the beam is over reinforced? Concrete will crush before
So
steel.
brittle
Steel
failure will be there.
Yeah, brittle failure. So to avoid that brittle failure, code says that it is putting maximum limit or providing what AST max that you can provide in your BD. Okay, accordingly you have to change the size of the beam, or uh, you have to go for doubly reinforced section. But the percentage, AST percentage or percentage of tensile reinforcement shall not exceed 2.5% of the cross section. Clear? So the first thing is for minimum and second thing is for maximum. So you can see that clause number 6.2.2 says the provision for maximum allowed, and the 6.2.1 says the provision for minimum. Clear?
Sir.
Yeah. Now you can see longitudinal steel on bottom face of the beam framing into column at the face of column shall be at least half the steel on its top face at the same section. Then at exterior joints, the anchorage length calculation shall consider this bottom steel to be tension steel. We'll talk about this a bit later, because in that case, I will have to give you this. I will have to explain it through the sketch. Okay, you can see this longitudinal steel in beams at any section shall not be at least 1/4 of the longitudinal steel provided at top face. Again, that we'll see. And this is very important. The anchorage, top and bottom bars of the beam at the discontinuous end. You can see this is your discontinuous end, and the anchorage of the bottom reinforcement as well as top reinforcement, whatever is the anchorage length, you can see that this is the anchorage length. It shall not be less than LD, or you can check it, equal to development length of the bar in tension plus 10 times bar diameter minus the allowance for 90-degree bend. Now this 10 times bar diameter and minus this allowance for 90, they are almost equal, and that's why we say that the development, it shall not be less than, available LD shall not be less than required development length. Okay. Achha, how many of you know the criteria for development length and why it is required? Anybody?
So to provide proper bond so that it will not come out of the support reinforcement.
See, you're right, but let me explain it through this. See, this is your bar, and let's say this is your concrete face. Okay, this is your concrete face, and this bar, let's say somebody is pulling, and because of that, a stress developed is sigma. Now, who is going to resist this stress? This
Increase
area,
length. Increase length.
right? A friction between concrete and this bar will resist. Now, if this bar, this stress is more than this frictional resistance, then the bar will get pulled out,
No.
right? And
Yes,
that
sir.
is why the development length is required. And what is the development length over here?
Frictional area.
Let's say I'm saying
Frictional
this
area.
as LD, this as LD. How much LD I need? Now you can find out. Let's say in cross section, this is my bar. This is my bar, and in periphery,
Periphery.
how much I will have pi d.
Pi d into a
So
area.
pi d will be my periphery.
Periphery.
Okay, pi d multiplied by length
LD.
LD, right? Multiplied by shear stress, that is tau, tau c for concrete. So this will be a resisting force.
Yes.
Clear?
Yes, sir.
Yes, sir.
Yes or no?
Yes, sir.
And this is equal to sigma. Now, if sigma is more than this, then the bar will get pulled out. And if this resistance is greater than this sigma, then this resistance will not allow the bar to get pulled. Okay,
Yes, sir.
and that's why you need LD, because you once you have defined the diameter of bar, you cannot change this. This is constant. Then this is stress that concrete can have, and you know that as the grade of concrete goes on increasing, the frictional stress of the concrete also goes on increasing, and you can get it from your books or codal information. So that you know it is something around 2.5 for M25, or it is max, it is something around 3.8 Newton per mm square. So that is the frictional resistance offered by concrete. So that concrete grade of concrete, right? But once you have defined your grade of concrete, let's say I'm using M25, then this is also fixed. So it is also not changing. Uh, D is also not changing. Sigma depends on external forces. Only the thing available to me is LD. And that's why I'm trying to define LD something like this, so that the bar will not get pulled, right?
Yes,
So
sir.
I'm showing you the concept behind that, and then you can go through the books and find out the relevant formulas, because mathematics you can get it, unless you cannot understand unless you have understood the concept. So this length, total length will decide whether the bar will get pulled or not. And now you will see that this is also one of the indirect approach that code has provided, because if you are going to use, let's say you're having a column something like this. So this is your dimension, width of the column. Let's say width of the column is something around 200, because code says that it shall not be less than 200. And this is your beam. Okay, so this is your beam. So if I go in section, I will see a column like this, and I will see a beam something like this. And if I'm providing a reinforcement over here, so already this is 200. Okay, so out of that, the cover on this side, so let's say 50 will be deducted. So I'm having only 150 as the length, 150 as the length available available length that I can anchor the bar. Clear?
Clear, sir.
And now if this bar is heavily stressed, that means the sigma tensile stress in this bar is heavily stressed and you are providing only 150. So it is definitely, it will have a possibility to get pulled out when the loads are applied and the full tensile stress is developed, because this will depend on external forces. Yes.
Yes, sir.
So you will have to bend it something like this. But if you are having height of the beam, let's say height of the beam, let's say this is 450. So this is 150 and maximum you will say that this is 300. So 300 plus 150, you will get 450. Okay. And what is your LD requirement? Your LD requirement, let's say this is your 20 dia bar. So your LD requirement is something around 1000. 50 times diameter. Yes. Or let's say this is your bar of 16 dia, then you need 1800. And what is available? That's why code says that this width shall not be this. Minimum 300. We'll go to the column and we'll see the requirement of B by D ratio for size of column. पता चला? अगर आप 200 के कॉलम करेंगे तो आपको ये प्रॉब्लम आने वाला है. You cannot detail your drawing because development length is required much, and you will see that your bar is coming out. And let's say this is your top, this is your rooftop. What will happen? If there is a floor, then this column will be going up. But if this is a rooftop, what will happen? You are not getting sufficient development length. And then you will say that, sir, I will bend like this. But that is not a good idea. So, and that is why the code is giving you the warning that don't go for slender beams, slender size of the columns, 200 by 1000, or so the accordingly provide the cross-sectional sizes properly so that these detailing you will not be in trouble when you want to find out this detailing, right?
Yes, sir.
And this is the reason why most of the practical structure engineers say that कोड वालों को कुछ समझता नहीं है, अरे वो एलडी अवेलेबल ही नहीं उधर, मैं क्या करूं? अरे तुमने पहले से ही गलत किया ना, तुम्हें किसने बताया 200 का कॉलम लो? यू शुड हैव गॉन फॉर 300, राइट?
Right, sir.
तो वो नहीं समझ, and that is why I'm giving you this. There are n number of provisions that people in practice say that नहीं वो code कुछ भी लिखता है, ये तो possible ही नहीं है. Yes, that is not possible because you have made a mistake right in the beginning. Because why? Because client says, वो architect बोलता है नहीं नहीं यार 200 कॉलम का वेट 200 रखो, बाकी डेप्थ कुछ भी ले लो, वो 1000 ले लो, 1200 ले लो. दैट इज नॉट द सॉल्यूशन. वो आपको आर्किटेक्ट के साथ बात करनी पड़ेगी, उसको बताना पड़ेगा भैया ऐसा नहीं होता है. यस, होता है ना?
Yes, sir.
तो ये देख लेना. Then this is about splicing of longitudinal bars. You can read that, and that is again this is exactly what is happening. So this here you can say that from this bar on this side as well as on this side, you must have uh, greater than LD. Okay. So this, and then because of the splicing, see what is happening at splicing, a stress from this bar is relieved
Awesome.
and concrete catches the stress, and then that concrete transfers the stress on this bar. See, this is the bar. Now this bar says that अभी मेरा एरिया खत्म हो गया, मेरे ऊपर जो भी कर्जा है वो मैं किसी और के ऊपर डाल देता हूँ. तो वो जो प्रोसेस वो स्मूथ होनी चाहिए ना. यस. हेलो.
Yes, sir.
See, okay, let me show that. See, this is the bar. This is the bar which is ending over here. बराबर. इसका मतलब ये बार जो स्ट्रेस कैरी कर रहा है, this is the longitudinal stress that is carried by this bar. अब उसका एरिया खत्म हो गया तो ये स्ट्रेस का क्या होगा, कौन लेगा? द कंक्रीट. और दूसरा बार, तो ये जो दूसरा बार है, ये दूसरा बार, see the stress from this bar is transferred on the concrete, and concrete will transfer the stress on this bar, and that transfer mechanism must be smooth. If it is haphazardous, then there will be cracking, and you will always find wherever there are insufficient development length provided at the time of lapping, uh, you find some sort of cracks in the beam, or some sort of that crack is getting developed and it is further improved like this. Okay. Now for that a sufficient, and that is it should be greater than LD, and in that portion also the stirrups. So these are the stirrups. These are the stirrups. These stirrups shall not be placed, or the spacing of the stirrups shall be less than 150. Actually, if this is the middle part of the beam, and most of the time you will see that it is somewhere near the middle, or away from a middle, and this type of lapping where the bars are heavily stressed and the stress is transferred on another bar, and that transfer mechanism उसमें गड़बड़ हो जाता है, and the cracking you will see. Now when this cracking will start develop, see this will be the cracking, right? ये ऐसा ऐसा cracking होगा ना? Yes or no?
Yes, sir.
Now this cracking will be arrested by this shear stirrups. अगर ये लोग भी नहीं है, then this cracking will get furthered, and you will see failure, something like this. So this cracking has to be stopped by someone. Now because main wicket तो आपका यहाँ गिर गया है, सचिन तेंदुलकर फेल हो गया, तो बाकी लोगों ने तो कम से कम सहारा देना चाहिए कि नहीं टीम को? यस और नो?
Yes, sir.
ऐसा तो नहीं होता ना कि एवरी टाइम सचिन तेंदुलकर विल प्ले एंड ही विल कैरी द गेम अप टू द विनिंग लेवल. कभी कभी वो भी फेल हो सकता है. अब वो फेल हो गए तो बाकी लोग बोल रहे हैं हम क्या करेंगे यार, सचिन फेल हो गया तो इट इज बाउंड वी आर गोइंग टू लूज द मैच. ऐसा नहीं. उस टाइम ये सेकेंडरी मेंबर्स विल कम एंड take the game in their control, provided they are having enough strength. And that's why this 150, even if in this area spacing of the stirrups, let's say spacing of the stirrup calculated by you is something around 200 center to center, even then you should not go for this, go for this, or I will say that go for 125. Wherever you are lapping your longitudinal reinforcement at bottom as well as at top, if you are lapping your reinforcement, you should go for stair of spacing equal to 125. Code says that it has to be less than 150. How much? It is up to you, but it shall not exceed. It shall not exceed 150. That is what code is advising. आप बोल सकते हैं चलो यार मैं और कॉन्शियस हो जाता हूँ, मैं 100 पे रखता हूँ. If your client allows, you can go ahead, because that will be conservative. But under any circumstances, it shall not be 150. फिर आप बोलेंगे नहीं नहीं सर, मेरा तो कैलकुलेशन ये बोल रहा है कि स्पेसिंग तो 300 रखा तो भी चलेगा. Even then, I am providing 200, so I am on conservative side. No, you are not conservative because you have not considered this local failure. This is called a local failure. It is not your calculation failure. समझ में आ रहा है ना?
Yes, sir. Yes, sir.
And this is where maximum people fail, because हम लोगों को ऐसा लगता है ना यार, क्या वो लैब भी वो सब वो छुटपुट बातें है. वो मैं prime I'm the main consultant and I will not look into the share of spacing and lapping. वो तो मेरे जूनियर देखेगा. मगर जूनियर को ये पता नहीं है. This is very detrimental and it is leading to brittle failure, because shear failure is always brittle. And you can see these are the cracks. These are the cracks at lapping, because your lap LD, the first thing is that your LD is less available. Okay, you have not provided lapping up to LD, whatever LD. Let's say 20 dia, then you must have this distance equal to
1000.
1000, and stirrups to be provided as 150, at least 150. Less than 150 is okay, or I will prefer. But if somebody is putting pressure on you, क्योंकि वो कॉस्ट बढ़ता है ना, नंबर ऑफ स्टीयरअप बढ़ गए तो बहुत बड़ा स्टील गया और उसका इकोनॉमी फेल हो गया. So that is called a false economy. Okay, we'll go ahead. And then this is about mechanical couplers, weld splices. You can go through that, and this is very important. This is very important, how you are going to use it. So this is how your stirrup should be having. So this length has to be, in case of 90-degree, or this has to be 135, and it shall not be less than 65 times diameter of stirrups. Clear? So this you can see that, see 6D or 65. So earlier it was 8D and something around 80, but I don't know why it has been reduced. But now code says that okay, 60 is well and good. We can accept. Okay, so that means if you are using 8 dia stirrups, then 80 into 6, something around 50, but shall be more than 65. And if you are using 12 dia stirrups, then how much it is? 12 into 6, 72. Now you can say that it has to be greater than 65. That means here you have to go for 75. So like that, yeah, you can calculate and see the things. Okay. So minimum diameter of the link shall be 8 mm. Then shear force capacity of the beam shall be more than larger of. Now this is very important. Larger of factored shear force as per your linear calculation, and factored gravity shear force plus equilibrium shear force when plastic hinges are formed at both ends of the beams. और ये नहीं समझता है, समझा है किसी को ये इसका मीनिंग? अच्छा, आप बोलेंगे सर अभी पहली बार देख रहा है, पढ़ा ही नहीं तो समझेगा कैसे? तो ये तो आपको पता है. So that is what you call as VU design.
View.
Okay, VU design. As per your calculation, whatever analysis that you have carried and whatever so that is linear structural analysis. So that is given. So everybody knows this. But what about this? Factored gravity shear force plus equilibrium shear force when plastic hinges are formed at both ends of the beam. That is sway to right and sway to left. ये नहीं समझता ना?
No, sir.
स्टील स्ट्रक्चर्स में पढ़ा है सर.
पढ़ा है मगर समझा है क्या? That is important.
नहीं सर, प्लास्टिक इंच तो सर लोकलाइज्ड फेलियर रहता है सर. जैसे इंच बनेगी तो सर वो ऑटोमेटिक उस जगह से रोटेट हो जाएगा सर.
Right, right,
सेक्शन.
right. But that is you have covered that in steel structure. But why it is
Yes, sir.
coming? Why it is coming in reinforced concrete? Reinforced concrete structure में तो हम प्लास्टिक डिजाइन मेथड यूज नहीं करते ना.
तो
अल्टीमेट
जनरली
लोड
सर
थियरी.
सर वो यील्ड लाइन थ्योरी में सर दे रखा है सर, उसमें प्लास्टिक इंच बनेगी तो फिर क्रैक फॉर्मेशंस हो जाएंगी.
बराबर है, बट व्हाई वो बनेगी ही नहीं ना, बिकॉज वी आर नॉट गोइंग फॉर दैट थियरी. वी आर नॉट डिजाइनिंग आवर स्ट्रक्चर्स और आई विल से कंक्रीट स्ट्रक्चर्स with the theory of plastic formation of hinges. हम लोग अलाउ ही नहीं करते ना. We are using Limestad theory or Limestad method. It's not a theory, it's a Limestad method. Okay, then why it is coming in picture over this 13920? Because 13920 is providing you the detailing concept when you're applying that for earthquake resistant structures and ductile detailing theory. Okay, now the first thing is that again you can go back and see that what are your assumptions under minor, under moderate and under severe, right? लिंक हो रहा है क्या?
यस सर.
So you're saying that your lateral load resisting system that you are developing with the help of accepted damage, perceived seismic damage performance, वो याद आया?
यस सर.
That was your basic assumption. और उसकी वजह से आपने R equal to 5 या R equal to 3 या R equal to 7 यूज किया है, जो भी. But you have accepted some sort of damage in your structure when the structure is subjected to seismic forces or they are subjected to lateral loads coming arising due to seismic activity, right? इतना तो पता चला. Now
Yes, sir.
that minor earthquake, you say that the structure will perform in elastic manner. That means there will be no damage. When it is subjected to moderate earthquake, you say that there will not be any structural damage. Non-structural element, which are your partition walls, etc., etc., they may get damage that can be repaired. Under severe earthquake or when the building is subjected to lateral loads, severe lateral loads coming or arising due to seismic activity, in that case you say that okay, structural damage is also accepted, but the collapse is prevented. The building is not allowed to get collapsed. Damage will be there. Building may tilt, building may lean, building may form Pisa Manora. Yes, Tower of Pisa. पिक्चर तो देखा होगा.
देखा है सर, देखा.
तो बिल्डिंग वैसा हो सकता है, but it will not fail. That is your assumption, and you are saying that some accepted damage. So where you are accepting the damage, you are not accepting the damage in columns, you are not accepting the damage in joints, you are accepting the damage in beams. That means when the structure will be subjected to severe earthquake forces, the beam might form hinges at their ends. Clear?
क्लियर सर.
अभी थोड़ा थोड़ा आ रहा है ना लेवल पे. अब
आ रहा है सर.
या अब देखो, now this is your support. This is your support, and now this support or the beam is subjected to 1.2, that is 20% more load due to self weight and superimposed dead load plus live load. So 20%. We are analyzing the structure for 20% higher load. See, here we are not going for analysis. Here we are going to check the capacity. So that is different approach. So this is a capacity based approach rather than analysis based approach. Analysis में आपने वो सब निकाला, वो ईटैब में मॉडल बनाया, स्टैड में मॉडल बनाया, फोर्सेस निकाले, उसका 1.5 टाइम्स डेड लोड प्लस 1.5 टाइम्स लाइव लोड, वो सब निकाला, फिर वेरियस लोड कॉम्बिनेशंस जो हमने देखे वो सब निकाला. दैट इज द एनालिसिस. Here we are checking the capacity. What is the maximum capacity, right? And we are taking care that the analysis results are showing lesser loads than the capacity. That's why most of the time it is called a capacity based analysis or capacity based design or performance based design. Here we are talking about capacity of column, capacity of beam, capacity of joint, capacity of footing, etc. So we are talking about capacity. So मैं ऐसा देख रहा हूँ. That's why this 1.2 is coming in picture. Otherwise it should be dead load plus live load, no? Clear?
Yes, sir.
That's why you are finding out the shear forces with 20% increase working load. Clear?
Clear, sir.
So that is the result. So VUA and VUB are the results due to this 1.2 dead load plus 1.2 live load. Now this is the moment that is applied. Now you can see. Okay, थोड़ा analysis का concept भी देखना पड़ेगा. Let me show you that. Let us say this is my frame. It is a fixed. मैं जानबूझ के एक single story structure ले रहा हूँ. Okay, this is my structure. Now this structure is subjected to VB. Yes, clear? Now this VB I have calculated with any dynamic methods, equivalent static load method, whatever it is. So I have calculated the base shear that is due to the seismic activity. What is the maximum base shear? Now this base shear will be resisted, so you will apply it over here. And that, as it is a single story, this will be base shear. Yes, clear? यहाँ तक clear हुआ क्या?
Yes, sir.
Now because of this load, this structure will get subjected to like this. And as the slab I am considering rigid because I am considering the diaphragm. So diaphragm is something like this. Now this beam is not deflecting like this. The beam is just displaced like this. So it will go this side, then it will go this side, then it will go this side. So this will be a vibration. Yes, clear? Or not
Clear, sir.
Okay.
Clear, sir.
Okay. Now, because of that, you will see that your deflected shape of the building will be like this. That means you will have a moment over here, something like this, and something like this. So same nature. Or if it is opposed by this force, then the moment will be something like this. So this will be clockwise moment at one end and clockwise moment at another end. So let us say this is M1, this is M2. So total moment कितना हुआ? M1. So sigma moment. It will be M1 plus M2. Yes, and it will be registered by this. So you will see that this is clockwise moment. So it will form anti-clockwise reaction. So this will be forming anti-clockwise. So this is clockwise, and resistance will be anti-clockwise because it will be this. And this is the shear force due to sway to the left or sway to the right. Yes, sway to the right exactly उल्टा होगा. Sway to the right क्या होगा? There will be anti-clockwise moment at both ends, and it will be resisted by clockwise shear, which will form like this. Clear?
Clear, sir.
Okay. And that is exactly that calculation. So you can see that. So if this is if a sway is to the right, you will see a clockwise moment over here, a clockwise moment over here, and that is called as uh, MAS. So moment at A at support, and this is sagging. So because of this moment, the beam is getting in a sagging position, and because of this, the beam is getting at hogging. So this is MAS means moment at a sagging moment at A, and this is hogging moment at B, and together it will be resisted by upward force, and that is the calculation that you will see over here somewhere. Where is that calculation? Okay, that I'm not getting that calculation right now. It has to be somewhere. Yeah, this is that calculation. See, final shear will be shear due to dead load plus live load minus 1.4 times shear due to moment divided by LB. Clear? So shear at A, and this will be shear at B. So we will be designing for these shears. And for sway to the left, you will see that at VUA it will be minus, and at VUA it will be plus. You can see that sagging and hogging moments of resistance of the beam section at ends A and B, and this shall be calculated as per IS 456. LAB is the clear span of the beam, and VU DL plus LL, and at A and B are the factored shear forces. And that factored shear forces, here we are considering 1.2 dead load plus 1.2 live load. And you can see that partial safety factors for dead and live load shall be 1.2, and the beam shall be considered to be simply supported for this estimation. So that is exactly what is shown in the figure also, and you can go through that and you will find now. I think you will be able to understand that. Yes. And
Yes, sir.
finally, this is the design. Now you can see the first shear stirrup shall be away from face of the support, not more than 50 mm. So maximum 50 mm has to be first shear. See, from the face of the column, first shear stirrup shall be maximum at 50 mm. You may provide it at 25, 20 mm, 25 mm, 30 mm, shall not be more than 50 mm. So the first stirrup is provided at 50 mm from the face everywhere, where the distance will be calculated from the inner face of the column. Then these are the stirrups in in the range of 2D. Okay, so hoop spacing, and that spacing shall not be less or it should be less than d by 4 or 8 times diameter of beam, diameter of bar, this for which you are providing shear stirrups, or 100. So it has to be less than all these three, any lesser of all these three calculations. At this support as well as at this support and middle portion, you will have a spacing shall not be more than d by 2. Now, what is the meaning of this? Simple. This is for capacity calculation requirement. Now, what will happen? Let's say you are getting the spacing of the stirrups something around 75 mm. Then, in that case, you will provide that over here. But if you are getting the spacing of stirrups, say nominal stirrups, so nominal stirrups are having a spacing more than 200 or more than 150. In that case, you have to check these requirements, and then the lesser of this you will be providing in the span of 2D, and this is called a shear span. Then this is the middle part. So if you are providing to d by 4, then in this you can double, and that's why the spacing shall not exceed d by 2, and this is again d by 4 for the region of 2D, and where d is the depth, effective depth of the beam, and not the total depth of the beam. So let's say if I am providing a size of the beam as 300 by 600, that means my effective depth will be something around 550, 50 mm less. Roughly, I am calculating. You may calculate with the bar diameter, then clear spacing, etc., etc. But let's say something around 550. So effective depth, I am having 550. Then I have to provide in this 2D region. That means 1100 mm away from the face of the column, I must provide this spacing. So either 100 or 8 dB or d by 4, whichever is lesser. So now in my calculation, what is happening? 550 divided by 4. How much it is? Something around 125. Yes. Hello. Are you
137.5, yes.
okay? So something around 125 or more than that. And code says that it shall not exceed 100. That means in this region, I must provide a spacing of stirrups equal to 100, right?
Yes, sir.
And in remaining region, I may go for twice this, so 200. Clear?
Clear, sir.
Then minimum 2 bars for full length along top and bottom. You can see that top and bottom must have minimum 2 bars. Okay, so this is your shear design, and then you can read it so that it will be more easy. And now this is all about columns. Now whatever are the requirement, now you can see here they are saying that the minimum dimension of column shall not be less than 20 times diameter of bar. Now why this diameter of bar? Let's say you are providing 25 mm dia bar in your column, then according to code, now in practice people do not follow this, but according to code, the minimum dimension of the column shall not be less than 20 multiplied by 25. How much it is? 450. Yes. 500.
Yes.
So code says that if you are going to apply the codal, you are going to apply 13920 in your detailing, then see what your analysis says, that is different thing. You may say, because that analysis is giving you the reinforcement requirement, or sizing of column based on strength. Okay. But this 13920 is related to your ductile behavior. So a strength calculation is a different part and ductile behavior is a different part. Just like for strength criteria, you may need depth of the slab something around 100, but uh, that serviceability criteria says that the depth of slab shall not be less than 125. Just the same way, the ductile detailing criteria, if you want to follow it correctly, then the minimum dimension of column shall not be less than 20 times diameter of bar. Now, why the code is asking this? Because again, as we have considered in our joint, that provision of LD inside the joint becomes very problematic if you are not following these provisions, or it shall not be less than 300. मेरा ये पॉइंट पर बिल्डर्स के साथ और क्लाइंट के साथ हमेशा फाइट होती रहती है. फाइनली I make them agree with 300, and then I try to provide the reinforcement in the columns less than 20 dia, because even if I go for 20 dia reinforcement bars, then I need minimum 400 mm width of the column, which architect and client are not happy to provide for some vague reasons. समझ में आ रहा है क्यों क्यों यस 13920 के बारे में ज्यादा कंप्लेंट बाय द स्ट्रक्चर इंजीनियर्स क्यों होती है? नहीं अच्छा लगता ना लोगों को. सही चीज बताई तो, बट इट इज वेरी इंपॉर्टेंट. एंड चलो हम लोगों का तो एरा निकल गया, अभी हम लोग और 5-10 साल काम करेंगे, इससे ज्यादा नहीं काम करेंगे, मगर आप लोगों का करियर शुरू हो रहा है. एंड नाउ इन व्हेन यू विल बी हैविंग 5 years experience, 10 years experience, most of the time you will have to deal with the structures which are not less than 20 floors. And उस समय अगर आप, if you are not equipped with this ductile detailing and the implementation of the ductile detailing, if you are not following, what will be the problems? You will definitely be under trouble. And that's why I am stressing these points more and more. नहीं तो आपको क्या करना पड़ेगा? Don't use bar diameter more than 16 in the column. So in that case, then this 300 will be enough for you, because 300 multiplied, that 16 multiplied by 20 comes out to be 320. So you can say that, okay, 300 mm में काम चलेगा. Yes.
Yes, sir.
But how it is possible if you are designing say 25-story structure and you are saying that in columns I am not going to use the bar diameter more than 16 mm? Is it possible? Think like that, and then you will understand the things. So here, that is the correct, and you can see over here. See, अगर ये dimension आपको नहीं मिला ना, तो you are not providing LD properly, तो फिर adjust करना पड़ेगा. Clear? So minimum column width has to be greater than 300 or has to be greater than 15 times diameter of bar. So here it is saying. So these are the basic minimum requirements, and accordingly you have to define. But one thing is that if you go ahead with all these ductile detailing, then there are chances that client may get unhappy with you. But I don't know why. We are working for the for the better life of the structure. Okay, then you can go with relative strength of beams and columns at joint. Now I will here I will say that you can go through this, because this is how the pulling and pushing of the when the structure is subjected to lateral loads, what is happening at the joint. The top bar is at one fraction of time, a fraction of second, it is getting pulled. Immediately it is getting pushed. Then again it is getting pulled and pushed. So because of that, there will be heavy shear stress
Yes.
failure might come over here, and that's why if this joint is not strengthened enough, then because of that pulling and pushing, pulling and pushing, that activity will create a crack between the concrete and a reinforcement periphery. That means failure, and that failure is very detrimental. Once the joint of the structure get failed, your structure is going to collapse, and it will collapse in a brittle manner. Okay, so all that you can check it over here. So weak beam requirement, strong column and weak beam. Now whatever we are saying over here, that strong column and weak beam, that does not mean that beam we are expecting beam to get failed. We are saying that when I am comparing the strength of column with strength of beam, then in that constant I will say I am saying that the beam is having lesser strength than column. That means if the plastic hinge is going to form, it will form first in the beam, it will not form first in the column. Clear?
Clear, sir.
So the formation of hinges in the column first, then in the beams first, and then it will be in the column, and finally will be earthquake very severe. Finally, it will or the joint will get uh, stretched, but first beam. So it will dissipate the energy, and that is the idea behind strong column and weak beam requirement. Many times pressure feels that अरे ये क्या बता रहे हैं, ये तो beam को weak करने को बोल रहे हैं. It's not a weak. The strength of beam, if I am considering strength of beam or the moment carrying capacity of the beam with moment carrying capacity of the column, I will say that moment carrying capacity of the column is more than moment carrying capacity of the beam, and that is exactly you can see over here. So sigma moment, that is the moments that are carried by column, so at top and bottom. So at top, so moment at top, moment at bottom, that is sigma moment, and in the column is greater than or equal to 1.4 times moment carried at beams on the left, on the right, on the front, and on the back. There will be maximum, there will be 4 beams, and there will be 2 columns. Yes or no?
Yes, sir.
See, if I am having a column over here, so I'm showing the plan, then I may have a beam over here. I may have a beam over here. I may have a beam over here. And I may have a beam over here. So there will be 4 columns and a column below and column above. So this is column below and this is column above. Then this is beam on left, then right, and beam on left if it is there, and then beam at back and beam at front. So 1, 2, 3, and 4. So the moment or strength of the beams will be, I will say, sigma MB. That is 1, 2, 3, 4. Okay, this is MB, and moment that is adjoint this bottom column and top column, right? So moment capacity of the column, and this is moment capacity of the beams. Now this has to be greater than or equal to 1.4 times this. That means I'm having 40% more capacity of the columns than the capacity of the beams, and this way it is called a strong column and weak beam. Clear?
Clear, sir.
Prima facie, you may feel that अरे ये क्या ductile detailing, ये कहाँ बता रहा है कि beam weak करो, column strong करो. नहीं, इसका meaning ये है capacity of the beams and capacity of the column. If I consider at a joint, then total capacity of the columns shall be 40% more than total capacity of the beams. फाइनली वो यही चेक कर रहे हैं कि भैया कुछ भी हो जाए, अगर फेल हो रहा है ना तो पहले बीम होगा, बाद में कॉलम होगा, और आखिरी में अगर फिर भी अर्थक्वेक नहीं गया तो आखिरी में जॉइंट होगा और उसके बाद फेलियर होगा. टोटल बिल्डिंग विल गेट कोलैप्स्ड. Then this is all about how you are going to provide the reinforcement. You can read that. I don't think there is much that I can say, क्योंकि ये देखने से आपको पता चलेगा what is the requirement, and you have to follow this requirement, and then you will say that I have designed the high-rise structure with the help of 1893, and I have detailed it with the help of 13920. नहीं तो if you are not using 13920 and you are analyzing the structure and designing the structure only with the codal provision of 1893, the actual performance of the structure will be very, very different than whatever you are predicting, in case the structure is subjected to earthquake. Normally वो subject नहीं होता है, क्योंकि earthquake is a rare phenomena. Yes, ये रोज आता था ना तो हालत खराब कर देता था सबकी. अच्छा है 25 साल में एक बार या 50 साल में एक बार या 100 साल में एक बार आता है. आई एम टॉकिंग अबाउट सीवियर. आई एम नॉट टॉकिंग अबाउट moderate and that minor earthquake, moderate earthquake, we can design it without any fear. The case is that whether your building will stand if it is subjected to major earthquake. I mean a severe earthquake, not major, severe earthquake. 8.5 करेंगे. अगर 13920 फॉलो करेंगे तो डेफिनेटली it will perform as per your calculations. So you will predict the performance of the structure when it is excessively it is subjected to excessive lateral forces. So I think we'll stop over here. All these things you can check and you will understand it. There is nothing new into that. Conceptual understanding में जितना मुझे ऐसा लगता था कि I should talk about it, I have seen. Now you can go through all the other requirements and you can you can understand it. Purposely I am not talking anything about shear wall, क्योंकि इतना ही अगर आपको आ गया तो आगे शेयर वॉल का आप समझ जाएंगे. और ये नहीं आया तो ये पढ़ने का कोई मतलब नहीं, मतलब पढ़ लो मगर थोड़ा लेट समझ में आएगा. सो ऑल दिस you can go ahead and you can check it. So any query? So with this, now you can see if you want to calculate moment of resistance of a rectangular shear wall, see all these calculations. You have to go through all these calculations. Only then you can design a rectangular shear wall, and that's why people are using uh, ready-made software, because software will take care of all these calculations. Yeah, lambda, phi, theta, LW, XU, and then for different XU by LW, all that will be taken by software. तो ETAB लोग क्यों यूज करते हैं शेयर वॉल डिजाइन के लिए? बिकॉज ऑफ दिस. you can go through and you can see that sir ये तो सर के ऊपर से जा रहा है, लग रहा है ऐसा. अरे आप लोग है कि नहीं?
सो बीच में सर आपकी वॉइस थोड़ी गायब हो गई थी सर.
कहाँ तक?
सो जब आपने वो स्टार्टिंग में जस्ट ये लास्ट सेंटेंस जो बोला था वो ऑलमोस्ट सुनाई नहीं दे रहा था.
About this? Hello? Yes.
Mathematical calculation of shear wall.
Yeah. So I was talking about this.
Yes, sir.
यस
Yeah.
सर. आपने स्टार्टिंग का तो आ गया था समझ में, लास्ट का नहीं आया था. जब आप शायद ये बोल रहे थे कि सर घूम जाए मतलब चकरा जाएगा, वो शायद कंप्लीट नहीं हो पाया था
Yeah.
सर, इसलिए समझ नहीं आया.
That is what I was talking. See, if you want to
यस
design,
सर. या
if you want to find out moment of resistance of a rectangular shear wall section, then as per this clause, you have to follow all these calculations. You have to find out phi, you have to find out lambda, then for various conditions for XU by LW, whether it is वो जैसे है ना वो rectangular flange beam. So we see first we see that the neutral axis is within the flange. Then we say that neutral axis is outside the flange, but less than 7/3 DF. All that. So that calculation is found out over here. So if you want to find out this lambda, then you have to go for you can check it. So the lambda is calculated as axial force divided by FCK multiplied by TW and LW. So this is lambda. Then if you want to find out phi, then phi is 0.87 Fy rho over FCK. Then if you want to find out rho, rho is the percentage of reinforcement that you have used. So all this you can see vertical reinforcement ratio, AST divided by thickness of wall into length of wall. So all these things are complicated, and then you have to find, then trial and error is to be calculated. So this is for a condition where XU by LW is less than XU star by LW, where XU star, you can check out this, XU star upon LW is nothing but your you may go and see that this is maximum XU max. We used to find that XU max equal to 0.0035 divided by 0.0035 plus 0.002 plus 8.87 Fy over ES. So all that this is related to your rectangular singly reinforced calculation. So first you have to find out this case. Then if you are coming in this case where XU star by LW is less than XU by LW and XU by LW is less than 1, then you have to go for this case B, and you have to find out again alpha 1, alpha 4, alpha phi, all that. See, alpha 1 is like this, then alpha 2 is this, and alpha 3 is this, and then again this all depends with beta and gamma, and then 1 upon 3 beta, and then you have to see what is that beta and gamma. Then you can go and see that this is beta and this is gamma, this is gamma. So all that, it's a complicated formulation. Actually, it is very simple, and it is just finding out your basics, and then people are using all this. Instead of all this, people are using ready-made uh, Excel sheets or software, and they find a moment of resistance of rectangular shear wall. But manually, you can find out. So right now I'm preparing a Excel sheet based on all these calculations, so that I don't have to do it again and again. But if it is prepared, I might give it all of you. बट फिर भी कम से कम एक महीना तो जाएगा मेरा, क्योंकि आई डोंट गेट दैट मच टाइम. बट आई एम प्रिपेयरिंग दैट एक्सेल शीट फॉर क्रिएटिंग this moment of resistance of rectangular shear wall, so that I will just submit the values of mu and pu, and entire things will be calculated automatically, and it will give me whether it is coming in condition A or condition B. But again, I will say that if you understand this, it is okay. And if you do not understand right now, it is okay. But later on, you will come and you will see that नहीं ये भी हमको करना है. Clear? So this is all about 13920. अब आपको पता चलेगा क्यों लोग 13920 पढ़ना नहीं चाहते. मगर एक्चुअली अगर पढ़ेंगे तो it will be very beneficiary to you, all of you. And आप लोगों के लिए तो मैं कहूँगा this is mandatory. हम लोग जब पुराने जमाने में काम करते थे तो हमें इसकी जरूरत नहीं थी, because the maximum stories that we used to go for is ground plus 3, 4, maximum 5. But right now, you people cannot survive if you say नहीं सर मैं lateral load analysis नहीं कर सकता, मैं सिर्फ 3 story या 4 story डिजाइन करता हूँ. So I will say that okay, that's nice, but I don't have a place in my company for people like you. You will have to go. Otherwise आपको ये design field छोड़ना पड़ेगा. अगर if you are staying away from lateral load analysis, then I will say that stay away from the design also. ऐसा नहीं होगा कि you are not working on earthquake and wind analysis, and still you are managing a structural engineering position in reputed companies. अरे गहरे के साथ तो आप ऐसे भी काम कर सकते हो. वो बोलेगा कुछ भी नहीं, बॉटम में 2 बार डाल, टॉप में 2 बार डाल, दे हो जाता है. फाइनली क्या होता है? फाइनली आप जब डिजाइन करके देखते हो तो क्या होता है? बीम के बॉटम में 2 बार होते हैं, टॉप में 2 बार होते हैं, और डर लगता है तो और एक बॉटम में डाल दो, और क्या है? ऐसा भी लोग डिजाइन करते हैं.
वो सर अर्थक्वेक आने पे पता चलता है फिर.
वो बोले कि यार सबकी बिल्डिंग गिर गई, मेरे लिए क्यों परेशान कर रहे हो? अहमदाबाद में क्या हुआ? सबके बिल्डिंग क्रैक हो गए, डैमेज हो गए, फेल हो गए, कोलैप्स हो गए, तो चल जाता है. अब नहीं, सी दिस इज व्हाट आई वांट टू से. आपको ऐसा लगना चाहिए कि नहीं, मुझे इस फील्ड में टॉप में काम करना है, या बॉटम में तो कोई भी काम कर सकता है. मेरे पास ऐसे सेंटरिंग कॉन्ट्रैक्टर है जो 10वीं पास है, मगर खुद ही कॉलम का रिइंफोर्समेंट डाल देते, बीम का. और सर क्या 50 साल तो, अभी 20 साल तो हो गए, ये क्या करोगे आप? 9-18 का कॉलम लोगे, नहीं तो 9-15 का लोगे, नहीं तो 9-24 का लेंगे. हम क्या करेंगे? 230 बाई 530 का सभी कॉलम ले लेते, सभी कॉलम में 12 बार डाल देते, दो बार 4 बार 16 के डालेंगे, बाकी 12 के डालेंगे, और क्या है।
सही सर।
और ऐसे चल रहा है, काम चल रहा है, दे आर
हाँ।
डूइंग वर्क फॉर 5 स्टोरी 7 स्टोरी, और तो इससे ज्यादा क्या करोगे। नहीं, शायद आप लोग मेरे साथ सहमत होंगे,
यस
ऐसा
सर,
हो
यस
रहा है
सर,
आपके आजू बाजू।
यस सर, यस सर।
यस सर।
वो फिटर बोलता है ना, सर क्या करोगे, 2 बार नीचे डालना है, 2 बार ऊपर डालना है, और स्टीयरअप डालना है, हो गया बीम। 9-18 का दे दो, डर लगता है तो 9-21 कर दो, और क्या है। आपको सोचना है कि वेदर वेदर यू वांट योरसेल्फ टू बी रिकॉग्नाइज एज अ प्रॉपर स्ट्रक्चर इंजीनियर, और वो बाकी सारे कर रहे हैं, उसमें हम भी कर रहे हैं ऐसा। So if you want to do that, then you will have to go through this. But I think right now आप लोगों को बहुत सारा हमने दिया है, yes or no?
यस सर,
यस सर।
आगे आगे चल के कर सकते हैं,
यस
कम से कम, कम से कम ये क्लास ज्वाइन करने का इतना तो फायदा हुआ कि क्या है आगे, ये तो समझा।
एक बात
यस
मिल
सर,
गया सर।
डेफिनेटली।
या फॉलो करने के बाद, सी you will become expert only when you will work on it. सिर्फ क्लास ज्वाइन करने से, क्लास अटेंड करने से, या बहुत सारे वीडियो देखने से कोई एक्सपर्ट नहीं बनता है। यू विल हैव टू जंप इन द वाटर एंड टेक द रिस्क टू गेट सॉल्व और ट्राई टू फाइंड आउट। तो थोड़ा थोड़ा एक्सरसाइज कर लो, आगे जैसे जैसे आप आगे बढ़ोगे ना, आपको इस फील्ड में हेल्प करने वाले भी मिलेंगे। ऐसा नहीं है कि सारे लोग आपको परेशान ही करेंगे। यस, पीपल आर देयर हु विल ट्राई टू डिमोरलाइज यू, बट पीपल आर देयर हु विल हेल्प यू। सो जो हेल्प कर रहे हैं उनकी मदद ले लो और आगे चलो। ओके,
यस सर।
या क्योंकि जो जो आपको परेशान करने वाले हैं वो तो परेशान ही करेंगे। बोले यार नहीं, हम लोगों ने 50 साल काम किया तब जाके समझा, अभी क्या करेगा तू, आगे चल के कुछ नहीं होते, यहाँ पे पैसा नहीं मिलता है, पेमेंट नहीं मिलता है, ये वो। डोंट डोंट लुक इनटू दैट। दे आर स्टीलिंग योर ड्रीम, एंड डू नॉट अलाउ टू स्टील योर ड्रीम। आपका पैसा किसी ने चोरी किया, मैं कहूंगा चलो ठीक है, आप दोबारा कमा लोगे, कोई बात नहीं, मतलब अच्छी बात नहीं है, मगर फिर भी यू कैन गेट आउट ऑफ दैट शॉक। बट अगर किसी ने आपका सेल्फ कॉन्फिडेंस ही चोरी किया ना, तो यू विल नेवर डेवलप दैट। होता है ना।
होता है सर।
हाँ, तो नेवर अलाउ अदर्स टू स्टील योर ड्रीम, टू स्टील योर पोटेंशियल, और टू स्टील योर करियर। उसको बोलो यार नहीं आता है तो क्या, मैं पढ़ूंगा, मुझे पता है बहुत सारे लोग हैं जो मुझे हेल्प करेंगे। अभी नहीं आता है तो क्या हुआ, बाद में आएगा। ठीक, क्या होता है, सी राइट नाउ, अगर आप समझो आप किसी के पास नौकरी के लिए गए, और उसने कुछ ऐसे आड़े टेढ़े सवाल पूछ लिए जैसे मैं अभी पूछ रहा हूँ, तो डेफिनेटली यू आर नॉट गोइंग टू आंसर देम, और यू आर नॉट राइट नाउ, यू आर नॉट कैपेबल टू आंसर देम, बट दैट डजंट मीन दैट यू आर नॉट एट ऑल कैपेबल। अभी नहीं है। उसको बोला सर प्रिपेयर करके आता हूँ, मिलना 15 दिन के बाद, मैं देखता हूँ। क्लियर?
क्लियर सर।
Okay, then I think tomorrow we'll start with ETAP, because I want to finish this. That's why I have gone for this extra session. And tomorrow we'll start with that ETAP model, and we'll see how the results are interpreted. And then practical, we'll be working on that model, practical reasoning. So do join tomorrow. And I think you people are not bored. You're 7:30 to 9:30. Now it's about 2 hours.
Yes.
बोर हो गए तो बोल देना बाबा शाह जी,
नहीं सर, बहुत अच्छा है।
बहुत बोर हो गए?
नहीं सर, बहुत अच्छा है।
अच्छा अच्छा, मैं बोला आप बोल रहे हैं सिर्फ बोर नहीं, बहुत बोर हो गए। Okay, then with this, we'll conclude to this session, and tomorrow at 7:30 we'll directly start with that ETAP model that we have shared with you, and we'll see how it is created, what are the basic things. I will explain, and then we'll go to results. Okay,
Okay, sir.
Okay,
thank
sir.
you.
Good night, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Good night,
Good
sir.
night, sir.
Good night. Good night. Good night.